Hello family, this is lesson 84. In this lesson we are going to move into good sampling methods. In fact, today in this lesson, or right now, we're talking about the best sampling methods that there are. So let's just take a minute to go through where we've been so that we can feel good about where we're starting. The first thing that we talked about was making sure that we're really clear on our population and our sample. We have to make sure that they match each other. It's extremely important that our sample represents our population, or else we can't make conclusions and find estimates, find the values that we want to find. Then we talked about how we can collect data. So there are three main types of collecting data. There's an experiment. That's going to be our last and final unit. There's a simulation. This is the only one that we've really done in class together. And then there's sampling, which is what we're focusing on right now. So focusing on sampling, we talked about the bad ways to find a sample. Often it's easier to highlight the good methods by starting with the bad methods. The reason that these methods are bad is because they produce biased samples. And biased samples cannot be fixed. The biggest issue with bias is that we can't fix it. We waste time and money taking a sample that we can't even use because in this case, we took a sample using a method that typically ends up with a sample that does not represent the population. So the simplest good methods that we know of are simple random samples. So the easiest and simplest are SRSs, simple random samples. We learned three different simple random samples, and they're in our notes in the order of difficulty. So the easiest, at least in my opinion, is HAP method. It's the easiest to describe and it's the easiest to understand. Then we talked about using technology. So you have two options here. You can use your calculator or you can use a website. And then for me, the most complicated method is the table of random digits. So if they ask you to use a specific method, they're usually asking us to use the table of random digits. And even though it does feel more complicated compared to HAP method or using technology, this is still considered a simple random sample. So this is supposed to be one of the easier samples that we can use. So population versus sample, how can we collect data? The data collection method that we're focusing on now is sampling. It's called sampling. We have three basic ways to take a good sample. They're all SRSs. And today, I should stop saying today, in this video, we are moving on to the best methods. And unfortunately, they're the best methods because they're the most complex methods. So all of these methods are complex. They are not SRSs. So that's one of the first things to note that is very important. These methods are not SRSs. So you have three more sampling methods. There's three more sampling methods here. None of them are a simple random sample. That's why when we did sampling distributions, confidence intervals, and significance tests, it was very important that we were distinguishing between a random sample and a simple random sample, because a simple random sample is a specific thing. These methods are better because they're more complex and, or I shouldn't say and, but they're not simple random samples. So the most basic is a systematic sample. And these graphics that we have here on this page, Hopefully, however you got these notes, they're in color, because the people in the sample are in color, and then the people who are not in the sample are grayed out. So these graphics are supposed to help us understand the type of sample that we're taking. So systematic sample is where you randomly select one individual from the population, then select every nth individual after that to be in the sample. So to find out what n is, we typically do n, so your population size divided by your sample size. So when we talk about a systematic sample, we need to know capital N and little n. Now, this method does not make so much sense until we see a different example. We do have a small population and sample here to kind of give us an idea, but the next problem we do is really the one that illustrates what a systematic sample is. So, in this systematic sample, we start with the second person, then every other after that. So a different way that you could see this is we are going to randomly select a member from the population between the numbers 1 and 20, and then we're going to choose every fifth person after that. So like I said, I am going to give you a better example of this on the next page, but anytime they're telling you, you sample every 8th person, or 10th person, or 5th person, that is a systematic sample. The issue, well, I guess I shouldn't say it's an issue. The reason why this is not a simple random sample is because not every member of the population has the same chance of being chosen. So after this first person is selected, this person that's grayed out has no chance of being chosen. This person grayed out has no chance of being chosen, because once you find that first person, it's only every nth person that you take after that. In a true, I shouldn't say true, in a simple random sample, every member of the population has the same chance of being chosen. So this guy has a 1 out of 10 chance, 1 out of 10, 1 out of 10, 1 out of 10, 1 out of 10. All of these individuals have a 1 out of 10 chance of being chosen. But in this case, in a systematic sample, just like I said, after you choose this first person, there's 0 chance you can choose him. 0 chance you can choose him. So that's why this is not a simple random sample, because every member of the population does not have the same chance of being chosen, because some won't be chosen. And 2, every sample of size 5, so this is a sample of size 5, n is 10, little n, I should distinguish, capital N is 10, little n is 5, not all groups of 5 have the same chance of being chosen. Once this guy is chosen, the only group of 5 you can have are the ones that are colored in. So, biggest takeaway from a systematic sample is that not every individual or every sample of the same size has the same chance of being chosen. And you're looking for the phrasing every 3rd person, every 5th person, every 8th person. That indicates systematic sample. Now, the last 2 are the most complicated ones. The best sample that you can take is a stratified sample. The best sample that you can take is called a stratified sample. The reason that it's the best is because it has a statistical advantage. So where do I want to write this? I'm just trying to decide. So this is the best one because it has a statistical, so I should write has statistical advantage. Meaning, this is going to give you the best sample possible. This is going to give you a stratified sample, will give you the best sample possible. So, the basics of a stratified sample is that you divide the population into smaller groups known as strata. Within each stratum, you select an SRS, then you combine all the SRSs to make a sample that looks like the population. So here for some reason, I lost the blank. So we need to write the word population. Maybe I'll write it below. Okay, just like a systematic sample, the example on the next page does a better job of illustrating what this really means. So, when we say divide the population into smaller groups known as strata, one of the things that we know is that the strata, so the individuals in a strata share some characteristic. Sorry, the individuals in a strata share some characteristic. So let's talk about that example of the athletic supporters. So the parent who is opposed to the budget cuts to the athletic program, she chooses a convenient sample of people at the football game. And I was telling you guys that this is not a good sample because all of the people that have a say in our budget, they are called stakeholders. And there are many different stakeholders in a school system. So there are teachers, administration, people that work for the district. There are students, the people that the money is going toward. There are community members. There are parents, and typically parents will be members of the community. So if we only look at the parents as our sample, we don't have any representation of the other groups. So if all I do is take a sample of the people at the football game, many of those people are going to be community members. How many of them will be teachers? Probably very few. If a teacher is at a football game, they're probably taking the tickets at the door. So you're going to end up with a sample of 60 people that probably has a lot of community members, maybe one or two administration, and I doubt that there's any teachers. So, and I should say, I doubt this parent is going to ask any students. I think that they would probably go and ask the grown-ups that are around. So a way to get around this is to take a stratified sample because you want to make sure that you have representation of all stakeholders. You want representation of the employees, the students, and the community members. So the way that you get that representation is that you group people by the thing they have in common. So this first group could be employees of the district. So this would be like teachers, administration, lunch ladies, secretaries, all of the people that work for the district. Then we could group the students together. Then we group the community together. And by community, I mean parents and the people that pay taxes toward the budget. So over here where I say individuals in a strata share some characteristic, these are all people employed by our district. These are all students of our, I shouldn't say district, I should say school, because this is a school budget. So these are all of the employees at our school. These are all of the students at our school. These are all the community members that pay taxes toward our school. If you compare them to each other, they're different. Employees of the school are different than students of the school, but within each group, they're the same. So I'm going to say that one more time. This is a strata, this is a strata, this is a strata. This strata is employees. Everybody in this group is the same in that they are an employee. This strata is students. If you compare these two, they do not have, well, I shouldn't say they do not have things in common. I should just say they're different. So that's what this means. Individuals in the strata share some kind of characteristic. So you have to be careful because each stratum does not look like the population. So if all you do is look at one strata, this is the problem that the convenience sample had. I am only asking employees of this school. I should be asking not only employees, but also students and also community members. So you have to be aware that you understand one stratum on its own, one strata, does not look like the population. But if you take 5 people from this strata, and 5 people from this strata, and 5 people from this strata, and combine them, you not only have a sample that looks like the population, but you also have fair representation within the sample of each type of person in the population. So the statistical advantage to a stratified sample is that it guarantees or ensures equal representation. So taking a stratified sample ensures that every group in the population is represented fairly. So we have the same amount of employees being chosen as students, as community members. We don't want to have 50 community members, 8 students, and 2 employees in a sample, because that basically is all community members. So I'm going to say that one more time. If we don't break these guys out into different stratas and take the same amount from each strata, you run the risk of getting too many of one type of member. So you could end up getting 50 community members, only 8 students, and 2 employees in your group if you take a convenience sample, or even if you take a simple random sample. So the takeaway here is, if you have distinguishable groups within a population, you want to make sure that you group those people together and take an equal amount of people from each group. If this isn't making sense, I highly suggest that after we do the next example, if it's still not making sense, you come back and listen to this part of the video until it makes sense. Okay? Okay. So, stratified sample has a statistical advantage. That's why it's the best method. And the reason that it is the best method is because it ensures or guarantees equal representation. Then the last one, the last complex method, is a cluster sample. This has a logistical advantage. Has a logistical advantage. So statistical means we're going to get a better sample. Logistical means it's easier. Actually carrying out the method is easier. The logistics, the planning, the going and getting the sample, the finding the time, the organizing the materials, all of that is logistics. Cluster samples have a logistical advantage because they're easier. Here's why. Cluster samples are often used for practical reasons like saving time and money. To choose a cluster sample, you divide the population into groups of individuals that are located near each other. So the key here is the only reason you're clustering them is because literally they are by each other, like in terms of distance and location. So, after you have your clusters, you will randomly select some clusters, and all of the individuals in the chosen clusters are included in the sample. Note, each cluster does look like the population. Each cluster does look like the population. So the example that we are going to use here is the estimating the proportion of people who think that we should continue distance learning next year. So this example is finding proportion maybe I should just write estimate proportion of stakeholders that think we should, actually let's put students. Continue DL Fridays next year. So the example that I'm going to use for this cluster sample is if we wanted to estimate the proportion of students that think we should continue distance learning Fridays next year. If our population is all students, that would mean that it's all students in our district. If we took a simple random sample, that means that we would have to be going all over the place to find these students, because it would include students from our school, from Granger, from Hunter, from Matheson, from Eisenhower, Jefferson, and all of the elementary schools. We probably shouldn't include the elementary schools, though. Maybe just the junior highs. Maybe even just the high schools, because in high school you're kind of old enough to like really have a super solid opinion, but the elementary kids probably shouldn't get to choose. So here's what we mean by a cluster sample. I could break the students into groups by school. So just in our area, there's Hunter, there's Cypress, there's Granger. I am choosing to group all of these students from Cypress together because they're literally together. They're by each other. They go to the same school. All of these students are near each other in the same school. Do they represent the population? Yes. They do represent the population. Hunter does represent the population. Granger does represent the population. So I break them into smaller groups that do represent the population, and then I randomly choose a whole group and survey everybody in the group. That is a cluster sample. It is easy because instead of having to survey 10 students from Hunter, 10 students from Cypress, 10 students from Granger, Olympus, Skyline, Kearns, so on, I can just choose one school and survey all the kids at that school. So some key words to look for here. Whenever it uses the word all, it is almost always a cluster sample. When it uses the word all or every, it's a cluster sample. So if anything in the prompt indicates that you are surveying or observing every single member in a group, that's a cluster. If you see 8th person, 5th person, 3rd person, it's systematic. And if they somehow indicate that you've broken your population into groups and you're taking a specific amount from each group, that's stratified. So, nth person, they survey every member. They take people from each group. Last thing on this page is a visual representation of the difference between a strata and a cluster. So if you were the salad quality inspector for Zupas, explain if you would use a cluster sample or a stratified sample for each picture below. Now remember, keep in mind what a salad looks like. It's got the lettuce and the extra bits like the corn and the tomatoes and the whatever else is on a salad. I don't eat salads, so that ain't my jam. I especially don't eat salads that have these ingredients. I eat like the berry salad. So, what is the difference between these two pictures? Well, if you look at A, you have a bunch of bowls with different ingredients. And if I look at one bowl, this guy's mushroom, I think that's corn, onion, that's the lettuce, that's the tomato. Each bowl has a different characteristic and they're all the same. So this is all tomatoes, all onions. If all I did was choose one bowl, would that look like a salad? No, it would look like a bowl of onions. So this is the strata. Or I should say stratified. You would have to take from every bowl and combine for it to look like a salad. This one's stratified. So remember up here, each stratum does not look like the population. Each bowl does not look like a salad. In order to make it look like a salad, you take from every group and combine. This guy just looks like a giant salad. This guy is a cluster. All of the ingredients are in here, and you could literally just grab a handful and it would still look like a salad. So this is a cluster because this looks like a salad. Hopefully that makes sense. So strata, cluster. In this case, the sample would be you like literally mixing it up, taking out a handful of ingredients and it looks like a salad. Here, you take a little from each bowl and combine it. Here, you take a handful or a scoopful. I guess we probably shouldn't be sticking our hand in the salad, especially nowadays. So sample here, take from every bowl. Sample here, grab a handful, and every single thing in your hand is your sample. Okay, this is the basics. This is kind of abstract, and I had to add in examples for you. You may want to add in context here for yourself, like remind yourself that I was using the football example here. If you're feeling unsure on this, just hang in there a little bit longer, because I think that this next example, the one where I taped these boxes to it, will clear things up for you, okay? Okay. Love you.